Have you ever wondered why it rains? It's a question as old as time itself, an inquiry shared by every person who has ever stood beneath a stormy sky, feeling the cool droplets on their skin. Rain is one of those universal experiences that link us all, regardless of where we come from or where we're going. It's a crucial part of our planet's life cycle, nourishing the soil, filling our rivers, and providing the vital water that all life forms need to survive. Yet, despite its ubiquity, rain holds a myriad of mysteries that continue to fascinate scientists and nature lovers alike. It's not just about water falling from the sky. It's a complex and beautiful process that involves the intricate dance of temperature, pressure, and moisture within our atmosphere. Our journey today is all about rain, that humble weather phenomenon that touches every corner of our planet. We'll be exploring the science behind those droplets that fall from the sky, the processes that create them, and the role they play in our world. You might be surprised to learn just how much there is to know about something as simple as a raindrop. Think about the last time you were caught in a rain shower. Did you ever stop to consider the journey those raindrops had taken to reach you, or the countless factors that had to align to create that moment? It's an incredible thought, isn't it? The beauty of rain is not just in the way it sounds as it taps against the window or the way it smells after a long dry spell. It's in the science, the journey, and the impact it has on our world. Our quest to understand rain will take us on a fascinating exploration, from the highest clouds in our atmosphere to the smallest droplets that make up a rain shower. We'll delve into the heart of storms, explore the life cycle of a raindrop, and discover how weather systems around the globe contribute to rainfall. Now that we've set the stage, it's time to delve into the science of rain. First, we need to understand the water cycle. This elegant, never-ending dance of water between earth and sky is essential to life as we know it. Imagine the water cycle as a grand ballet, with each step representing a different phase. The first step is evaporation, where heat from the sun causes water in our oceans, lakes, and rivers to transform into vapor, rising into the atmosphere. This isn't just happening in bodies of water though. Water held in soil, plants, and even you and me also evaporates, becoming part of this atmospheric dance. The second step is condensation. As the water vapor ascends, the atmosphere gets cooler and cooler. This drop in temperature causes the water vapor to change back into liquid form, creating millions of tiny water droplets. These droplets come together to form clouds. If you've ever looked up at the sky and marveled at the fluffy clouds above, you've seen condensation in action. Now, the final act, precipitation. When the water droplets in the clouds become too heavy to float in the air, they fall back to Earth as precipitation. This could be in the form of rain, snow, sleet, or even hail, depending on the temperature and conditions in the atmosphere. Throughout this process, the sun plays a pivotal role. Its heat provides the energy needed for evaporation, setting the whole cycle in motion. Without the sun, the water cycle would grind to a halt and life as we know it would be very different. But the cycle doesn't end with precipitation. Once the water reaches the ground, it's either taken up by plants, flows into rivers and oceans, or seeps into the ground to become groundwater. From there, the sun's heat once again causes evaporation, and the cycle starts anew. So, the water cycle is the fundamental process that brings us rain. But how does this process actually create a raindrop? Well, that's a story for another scene. Stay tuned to find out more about the fascinating journey of a raindrop. Raindrops don't just appear out of nowhere. They have a birth story that's as poetic as it is scientific. So, let's dive into the journey of a raindrop, shall we? It all starts with a tiny particle floating in the atmosphere. It could be dust, sea salt, or even smoke. This particle, often known as a cloud condensation nucleus, becomes the core around which a raindrop forms. As the surrounding air cools down, the water vapor in it condenses and forms tiny water droplets around our particle. This process is known as condensation. It's the same phenomenon that fogs up your glasses when you come in from the cold or beads up the outside of a cold drink on a hot day. But our droplet is still too small to be a raindrop, so it needs to grow. And how does it do that? Through a process known as collision and coalescence. As the droplet falls through the cloud, it collides with other smaller droplets. Some of these collisions are gentle enough that the droplets merge or coalesce, forming a larger droplet. This collision and coalescence process continues, and the droplet grows until it reaches the size of a raindrop. But there's a limit to how large a raindrop can get. If it gets too big, the air resistance causes the raindrop to split into smaller droplets. That's why even in the heaviest rainstorm, raindrops are around the same size. And finally, when the forces of gravity overcome the upward push of the air, our raindrop begins its journey to the ground. Depending on the height of the cloud and the size of the raindrop, this journey can take anywhere from 5 minutes to over an hour. That's the journey of a raindrop, from a tiny particle in the atmosphere to a droplet that quenches the Earth's thirst. That's the journey of a raindrop, but what influences where and when it rains? Stay tuned as we delve into that in our next segment. Rain doesn't fall uniformly across the planet. This statement may seem obvious, but have you ever wondered why it's so? The answer lies in the complex interplay of weather systems and geographical features. Weather systems, including high and low pressure systems, fronts, and wind patterns, play a significant role in determining when and where rain falls. High pressure systems, often associated with fair weather, tend to push air downwards, which discourages the formation of rain clouds. In contrast, low pressure systems draw air upwards, promoting cloud formation and rainfall. Fronts, the boundary zones between warm and cold air masses, are also key players in rain production. When a warm front pushes against a cooler air mass, the warm air rises over the cooler air, creating clouds, and yes, you guessed it, rain. The opposite happens in a cold front, where the colder, denser air pushes under the warmer air, triggering precipitations. Wind patterns, too, help shape rainfall distribution. Prevailing winds, the winds that blow predominantly from a single direction over a particular point on Earth's surface, can carry moisture-laden air over land, leading to rainfall. But what about the role of geography? Mountains, bodies of water, and other geographical features can greatly influence local climates and rainfall patterns. For instance, the phenomenon known as orographic rainfall occurs when an air mass is forced to rise over a mountain range. As the air rises, it cools and condenses, forming clouds and rain. The side of the mountain facing the wind, known as the windward side, typically receives more rain, while the opposite, leeward side, is often drier, a phenomenon known as a rain shadow. Bodies of water, too, can influence rainfall. Coastal areas often experience more rain due to the moisture available from nearby water bodies, so weather systems and geography play a crucial role in when and where it rains. But what about the different types of rain? Not all rain is created equal. This statement rings true when we consider the different types of rain that exist. The type of rain you experience is determined by atmospheric conditions, and today we'll briefly delve into a few of these types: drizzle, showers, and downpours. Let's start with drizzle, the gentlest form of rain. Drizzle is characterized by fine, light droplets that seem to float in the air. It's typically produced by low, thick clouds and doesn't fall at high speeds due to the tiny size of the droplets. It may not seem like much, but drizzle can create a damp and chilly environment, making it feel colder than it actually is. Next up, we have showers. Showers are a step up from drizzle in terms of intensity. They start and stop abruptly, and the rate of rainfall can change dramatically within a short period. You might find yourself walking under a sunlit sky one moment and getting drenched the next. Showers are usually associated with cumulus or cumulonimbus clouds, the ones that look like floating cotton balls in the sky. Finally, we have downpours, the heaviest of the lot. Downpours, also known as rainstorms, are characterized by their high rainfall rate and are often accompanied by thunder and lightning. They can cause significant drops in temperature and are usually associated with severe weather conditions. Downpours can lead to flash floods, making them a force to be reckoned with. Understanding rain helps us appreciate this common yet complex phenomenon. It's a vital part of our planet's ecosystem, and it's much more than just water falling from the sky. So next time you see those droplets on your window, remember the incredible journey they've taken to get there. Not only have they traveled through the water cycle, from evaporation to condensation and finally precipitation, but they've also been influenced by weather systems and atmospheric conditions to become the type of rain you see. The world of rain is a fascinating one, and we've only just scratched the surface.